And this is our official start today of big data. So today we're going to have a little bit of transition in our topics, what we're going to be working on this week. And I'm going to share my screen to talk about that. So yeah, right now I have our course schedule pulled up. And so the first 3 weeks of the course, what we've already finished, has been focused on these sort of DevOps issues. And again, DevOps standing for development operations. And it's sort of how you get the code that you're working with deployed into the real world and orchestrate all of these, bringing up your Docker containers and bringing them down. And yeah, getting all those puzzle pieces to work together so that the programs can actually run. And so we'll be building off of that. Basically, every week from here on out, I'll be giving you new Docker files and Docker Compose files, and we'll be working inside of them. But there won't be any big sort of create a giant program from scratch anymore. So hopefully things will be a little bit more, I guess, straightforward with the assignments, and there won't be like one little tiny gotcha line of code that if you missed it, then everything's going to break, but you won't know it's going to break until 30 minutes later when you're working on something totally different. And so what we're going to switch to is talking about this programming language called SQL and how SQL lets us interact with the database. And this first sort of 4 weeks of SQL, up until the last week is after spring break, what we'll be talking about is sort of why is SQL correct, or how do you make your SQL code correct? And then after that, we'll be talking about how do you make your SQL code fast. The midterm, again, will not be covering any of the DevOps stuff. This is just going to be sort of background knowledge so that you can complete the projects in the course. And the midterm is only going to focus on the SQL assignments, SQL code. Right now, the midterm, I have it scheduled for the week after spring break is when I'll give it to you. And it'll be a untimed exam. Basically, the only restrictions will be can't work with other students on the exam. Any questions about like administratively what to expect going forward? Okay. Then up here, we have this week 3 folder, which I've added. And before actually going into the material of this week, I want to highlight this, this homework repository right here. We're going to be going through the repository in class. And I know a number of you like to follow along in class, so I want to real quick go over how to get that repository downloaded onto your Lambda server account, because it's a little bit different. Not a lot different, but just a little bit different. And that way you can make sure that if there are kinks, you can get those ironed out kind of while I'm talking about the high level stuff. Okay, so this repository has a bunch of, you can see it has a Docker file and some Docker Compose files in it, and so it's going to bring up a database system for us that we'll be interacting with. And if we click here on this repository Pagilla, this is a sort of a famous repository for like an example Postgres database that a lot of people will just sort of work with just as you're learning SQL to get familiar with all the things that you can do. And so when you're cloning this repository so that you have access to it, you have to make sure that you clone it in a way where you get access to this other repository. And this other repository is called a submodule in Git language, sort of like a repository that's inside of a repository. And down here at the bottom, there's instructions on how to do it. It's these 4 lines right here that you run this git clone like normal. But then in order to actually fetch the submodule as well, you have to run these 2 lines right here. So I'm going to go ahead and switch over to a terminal, and we'll do that. there's the git clone command. And now I go into the repository that created, type ls, see all the same files, but here in this Pagilla file, ls Pagilla, you can see that it's empty right now. It doesn't contain the SQL code that actually generates the database. And so in order to download that repository, download that code, it's these two lines right here. First, git submodule init, and then git submodule update. And now if I type ls Pagilla, it has all that stuff inside of it. If I type ls from my root project folder, then here's the Docker file and the docker compose.yaml file. Let's just take a quick look at that docker compose.yaml file. We can see that it just has a single service inside of it called PG. So that's our Postgres database service. And if I do docker compose up, then it will bring that, that service up. And so we'll be interacting with this service sort of in the main part of the lecture where we go over how these SQL commands work and how to effectively work with SQL. Any questions about that? Okay, then we'll start. I'll have about 15 minutes or so of high-level overview of SQL and what are called relational databases. And then we'll start going into the code and how to run the code. So you'll see this acronym thrown around a lot, RDBMS, and this stands for Relational Database Management System. And effectively, it's just like a synonym for databases. That there are other types of databases. The 99% of databases that people use are RDBMSs, and that's the only kind of database that we'll look at in this course. And with this first Dilbert comment right here, sort of the joke about it is that it really doesn't matter what your problem is, like whether you're building a web application like Instagram, or if you're working at a bank and trying to manage people's money. It doesn't matter what your problem is. The answer is always a database system. That these systems are just amazingly complicated under the hood of what they do, and they provide such a simple interface for working with data that it's just always the answer. At first, the interface may not seem simple. The SQL language is going to seem rather different than other programming languages that you've worked with in the past. But after we start talking sort of in the next section, of course, about the making things fast, you'll see that just really how powerful this language is. So SQL stands for the Structured Query Language. Nobody actually knows what that is or what the acronym stands for. I had to look it up myself just to put it in here. And the one thing that you'll notice is that I'm pronouncing this SQL, like the word SQL, and not like SQL. Pronouncing SQL like SQL is sort of a shibboleth that you don't really know too much about databases. There are certainly good database people who pronounce it SQL, but 99% of the people who do databases pronounce it SQL. And so the joke of this comic right here is that we have the pointy-haired boss, and you see that in the text right here, it says build an SQL database. And I know that the pointy-haired boss pronounced it SQL because it says "an" right here. If he pronounced it the way a database programmer would pronounce it, he would have said build a SQL database. And so that's the flag to Dilbert here that the boss is about to say something stupid, and so that's the joke. If you pronounce it SQL at say a technical interview, nobody's gonna explicitly mark you off points for that, but it's just gonna be sort of a throw the interviewer off and like, does this person really know what they're doing? So SQL actually used to be written like this. So that's where the pronunciation comes from, but due to trademark reasons in like the late 70s, it had to be shortened back to SQL. If you are interested in like history, things like that, this blog post has the full history of the SQL language by the people who sort of administer it, the ANSI group. Okay, so comparing to other languages, most programming languages that you have seen so far in your career are probably iterative programming languages. So the standard examples are Python, C, C++, Java. And what the key thing about these languages is that you specify how to compute something. So first do this, then do this, then do this, and just step by step what to do. SQL is very, very different from that. It is a declarative programming language. And so instead of specifying how to compute something, you specify what to compute. Basically, what is the formula that you want computed? And the database, or a compiler within inside of the database, will convert that declarative program about what you want computed into an efficient imperative code that will actually do it. And there's a lot of great guarantees about this conversion process, and in particular, we'll see that it's provably guaranteed to have excellent performance, both asymptotically, so like big O notation-wise, and with good constant factors. And that's one of the sort of main reasons why, like, no matter what your problem is, databases are the solution, because when you're working with SQL in a database, you're guaranteed to always have optimal performance on all the queries that you're trying to write. There's this other sort of alternative to SQL for interacting with databases called ORMs. And in the assignment last week, I didn't need to look at the Python code in detail, but the Python code was using what's an example of an ORM. And in particular, they were using the SQL Alchemy ORM, and this is probably the most popular ORM in the Python world. And it's it is used by a lot of companies. So Reddit is probably the most famous one that uses it. But the disadvantage, or I guess first, the advantage of ORMs is that it hides the SQL interface to the database. So under the hood, it still uses SQL, but it hides it, so you don't have to know about this sort of declarative aspect of programming. You don't have to, you can skip this whole specify what to do and just go to specifying how to do it. Yeah, so at first, this might seem easier because you don't have to learn this new programming language, SQL. Keep working in whatever language that you're most familiar with. But what happens is you lose all of these excellent guarantees about guaranteed excellent asymptotic and constant factor performance. And so what a lot of companies find is that you can sort of maybe more easily get started with it because you don't have to learn another language, but it's much, much harder to actually scale your systems to large-scale systems. Twitter, as an example, they originally built their company on this programming language called Ruby, using this framework called Rails. So it's commonly called Ruby on Rails. But they found that it was just not good enough performance for them, and so they left. Now they use Java as their programming language, and they connect directly to MySQL, writing SQL code. Yeah, so this is whether ORMs are a good thing or a bad thing is something that is not like a settled question in the software engineering world. Personally, I think they're a bad thing. I think it's not really that hard to learn the SQL language, and the disadvantages of ORMs are pretty big. But other people disagree with me, and there's a pretty good discussion here at this link if you wanted to see what like other people's opinions are on the topic. Any questions so far? Okay. So in this class, the database that we're going to be focusing on is Postgres. And this link right here, the rather crudely named "How Fucked Is My Database" website, is sort of captures, I think, what the general consensus among sort of like, say, CTOs at companies are about which database you would want to use when. And so here's just a handful of different sort of famous databases. If you click on Postgres, it asks you another question, and no matter what you say for that, you say you get a pretty decent answer. You're probably okay. If you click on MySQL, then the sort of standard feeling that people have about MySQL is that people used to use it because it was fast, but now people really don't like it because computers are faster. We don't need the sort of optimizations that MySQL was doing. And MySQL has no guarantees that if you put data into the database, you'll be able to get it out. Postgres, that's sort of their thing, 100% guarantees. If you put data in, guaranteed to come out. MySQL doesn't have that guarantee. Actually, most of these other databases don't. Microsoft servers, another sort of popular one, but there was a famous incident a couple of years ago where actually a nuclear reactor had a severe problem with their operational functioning due to bugs in the nuclear reactor's code. And Postgres doesn't have those sorts of problems. Oracle's probably the main competitor at this point to Postgres in terms of features and sort of technical accuracy, but it also costs literally millions of dollars to license it. Really, the only people who use Oracle at this point are banks, and that's kind of for legacy reasons. That Oracle was created in the 70s really specifically for the banking finance industry, and a lot of laws and regulations actually specifically say that a bank must use Oracle in certain situations. So typical sort of tech companies would never touch Oracle, but for regulatory reasons, banks do. This other database right here, SQLLite, is another very popular competitor to Postgres. And this database is specifically for when you only have one person who is using your application. And in that case, this is the database to choose. And so if you look on like your Android phone or your iPhone, any one of the apps that's on those phones that's using a database is going to be using SQLLite as its database. My sort of like takeaway about which database to use, or at least the sort of personal choices that I make, is that if it's a cell phone app, something that guaranteed only one person is ever going to be interacting with, SQLLite's the right thing to do. Otherwise, I would install Docker and do Postgres through Docker. Let's see, some sort of two important stories. I'll start with the second one. So even, yeah, I've said a lot about sort of bad things about Microsoft in this course so far, both about with Windows, the operating system, compared to Linux, and about Microsoft Server or Microsoft's SQL database. But even Microsoft agrees with me that their sort of big data solutions, they don't use their own database. They don't use Microsoft SQL Server. Instead, they use Postgres with this sort of same Docker backend. And if you clicked on this link, you'd get to see a big case study from Microsoft about why they chose to use Postgres instead of their own products. This first important story here, and this is one that's really famous in the database world, but it's an example of what I was really emphasizing last class about production database keys. And you really, really have to be careful with those production database keys. Basically, what happens in this story is that the CTO of a company gave a new hire, somebody who just joined the company that day, the keys to the production database, and he gave them instructions on how to delete all the data in a database. And so, unsurprisingly, the new hire deleted all the data in the database, and the company went under because they had no backups. So the lesson from this story is you really have to carefully guard your production credentials for databases. And this particular link is one that everybody has read who's worked on databases. So it'd be a good link to check out. Okay, yeah, so I mentioned this a little bit before, but the next 4 weeks we'll be talking about how to make SQL correct. So really specifying like exactly what we want our SQL code to do. And then after that, we'll be talking about how to make it fast. So yeah, just at this point, the correctness part. Any questions about any of that high level stuff so far? Okay. Then this section right here has the like specific material that you need to know for your midterm, what will be on the midterm. So there's these 4 statements in SQL that you'll be expected to know. I'll go over them here in a second in the when we switch to the coding environment in the terminal. But we're really going to spend the most time on this select statement because it's kind of the most powerful, and that's where all the interesting stuff in SQL happens. And if you were to click on this link right here, then for this first week, what we're going to be covering, what I expect you to know is sections 1 through 4 of this link, all the way up to this point right here. And both your homework and again, your midterm will depend on that material. Okay, so let's go ahead and switch over to the terminal now. Let's clean up that screen a little bit. And we still have our database running over here. And so let's see, how do we connect to the database so that we can start running these SQL commands? And the, make this a little bit bigger here. The key command to remember for connecting to the database is Psql. Psql connects to the database. So the database is called Postgres. And so this P stands for Postgres, but Psql itself is the actual like program that you run to connect to the database. And to run this program, the easiest way to do it is to run it from within the container that is running the database. So here is our database container. If we did docker compose exec, PG was the name of the service, PG standing for Postgres. It's another common abbreviation for Postgres. And then Psql like this. So we've seen all this part before, docker compose, interfacing to Docker through that docker compose.yaml file. Exec lets us execute a piece of code inside of a container. The container we are executing it on is the Postgres or PG container. And the command that we are running is Psql. And you hit enter. And you get this error message saying role root does not exist. So you actually have to also explicitly specify which user you are logging in as. And so it's -- user, and then the name of the user. In this case, for this database, the user's name is just Postgres. And I hit enter. And now I know I'm inside of Psql on the container because my prompt has changed to be this. This is sort of like the key important thing about all of the previous 3 weeks of DevOps material. So are there any questions about how to use this command to actually connect to the database? Okay. Then the first command that I want to look at is the \d command. And anytime you see me type something in that starts with a backslash, this is a Psql specific command. So I'll do this, Psql specific command. In SQL, these dash dashes is how you start a comment. So it's no longer hashtags for comments, it's now dash dash. I often get confused when I'm switching back and forth between all these languages and start with a hashtag, but then realize it should be dash dash. Psql specific command, because it starts with a backslash. Oops. And I guess the comments don't even work on the Psql specific commands. So backslash D. And what this command does is it lists all of the relations inside of the database. And we'll talk in detail about exactly what a relation is, but sort of the right way to think about it is it's like a spreadsheet, like a table from Excel. And there's each one of these different relations stores different information that we might want to extract. We'll start by looking at this actor one, just because it's at the top. And well, actually first notice that after I ran that command, I'm in this sort of, we call this a pager environment right here, where we're looking at the results, the output of a command, and we can no longer type in a command. In order to get out of the pager environment and back into the normal Psql environment, you just press Q. Yeah, so backslash D by itself lists all the relations in the database, and backslash D, then the name of a relation, tells us about the relation itself. So here, I did backslash D and then actor, and this is all the information stored in the actor relation. This list of columns is sort of like, yeah, it's each column in our Excel spreadsheet. And that's sort of the main thing to take away from it at this point. There's a lot of things on the screen. We'll go over exactly what they all mean later. But at this point, just know that inside of the actor relation, so a table of actors, there's a number of columns: the actor ID, the first name, the last name, and this last update. In order to actually look at the contents of one of these relations, we use this select command. And select is actually part of the SQL standard and works on every database system. So again, if it starts with a backslash, it's Psql only. If it does not start with a backslash, it is an actual SQL command. And we'll start with select star from actors. The general formula for this select command is right here you have the information that you want to extract, and right here you have the table that you want to extract it from, or the relation that you want to extract it from. In SQL, the word table and the word relation are synonyms, so you'll see me using them kind of interchangeably. And I'll hit enter, oops, and I think it's just actor, not plural, and this is what we get. And you can see up at the top here is the same list of columns that we had before. So actor ID, first name, last update. And then there's one row for each entry in the database. These rows, sometimes they're called rows, sometimes they're called tuples, or sometimes they're called entries. And those are, again, just synonyms that all mean the exact same thing. And so this table, scroll up and down to see all of the results that was returned by the SQL select statements. In this pager environment, you can use a lot of the same key bindings as you use inside of Vim. So for example, the capital G or Shift G will take you to the end of the pager environment. And in this case, you can see that there are 200 rows, 200 entries inside of this actors table. You could also use the slash keyword or the slash command in order to do a search. So if I was looking for a specific actor, like let's see if there's an Oprah, and hit enter, and it will find the corresponding actor in here. And it searches all of the columns. It just does like a normal text search. So again, key things to know so far: these columns right here of the table are the same as when I did \D actor, this list of columns right here. This type right here tells me actually like what type of the information is going to be returned. And in Python, Python is an untyped language that if you have a variable and it's an integer, you can change it to a string or whatever other type. SQL is a strongly typed language. So write that out. SQL is strongly typed. And because of that, if a column is a text column, it's guaranteed to have text inside of it and cannot have a number inside of it, for example. Let's see, let's go over some of the, well, let's see, are there any questions at this point? Okay. So the, here with this select star from actor command, this is a just typical example of a first command that you might want to do, but it's not something that in practice you would ever want to actually run. This star right here, it's considered kind of bad form to ever do select star from some particular table. And instead what we want to do is select the particular columns that we're interested in. So here, select, instead of star, I'm going to say select last name, last underscore name, and first underscore name from actor. And this will just return whatever, whatever columns I have specified right here. The reason why the star is sort of considered to be bad form is because it's significantly less efficient from the database side to do select star than it is to do select with these names like this. I'll write that out. Select star, much less efficient. And the reason for this is all of the results from your select command have to be transferred over the network. And so you don't want to be transferring data that you don't actually need. In this case, it's a very small table and we're just kind of interacting interactively with the database. So we're not going to notice a performance impact. But if this was in, say, Instagram and there's thousands or millions of users connecting per second, it really matters how much network traffic you're putting over the network. And so you want to minimize that as much as possible. So it's always, this is the last time in this class you'll see me use select star, and it's always going to be select some particular set of actual columns. Let's see. So at this point, let's run this again. And you can see that there's sort of no ordering amongst these actors about how they're returned. And so let's see how we can get these to be returned in a maybe nicer order. And the way to do that is, let's see, we'll do the same command again, first name from actor, but now there's this order by clause that we can add at the end. The select command has, oops, and I need to spell order correctly, has many optional clauses that you can place into the command to alter its output to get different results. And here with order by, you specify particular columns that you want the output sorted by. So if we wanted the output sorted, say alphabetically on the last name, we could do order by last name and hit enter. And now everything is in alphabetical order. The default ordering that it uses is always from low to high. So alphabetically low to high would be A to Z. If it were numbers, it would be 1, 2, 3, 4, 5. Dates, everything has its own sort of ordering. If you want it to be high to low instead of low to high, then you can say DES at the end, standing for descending, and hit enter. And now it's ordered from Z down to A. One of the things that you'll notice is that the last names here are ordered. So Zellweger 3 times, and then W's and so on. But if you look at the first names, they're not ordered. So here, Julia, Cameron, and Minnie, there's no particular ordering to that. If you want to order by multiple columns, then it's order by, then you add a comma separated list of the columns you want ordered by. So first, last name, and then first name like this. And now things are ordered once again by both last name and first name. You'll notice though that here, the last name is now ordered in an ascending fashion from low to high. And the reason for that is because even though I still have this DES right here, this DES is being applied to the first name column, and it's not being applied to the last name column. If I wanted to order by the last name descending, I would do that. If I want to order by both descending, I would do that. And that kind of got messed up because it wrapped around the line. There we go. So last name descending, comma, first name descending to have them be both descending. There's no way in SQL to specify that, say, like all of the columns are being descending with just a single command. You have to manually specify each one as being descending. Any questions so far?
Yes. So when you specify order by both of them, so you can, so if each of the rows are supposed to be preserved, how can you sort them by like both the things? Because
Yeah. So what it does is it first sorts by the last name, and then whenever there is a like ambiguous ordering on the last name, so like all 3 of these have the same last name ordering, then it sorts on the first name.
Okay, I see. So so because you said last name first, it will first sort by last name.
Exactly, it goes in a left to right order. If I change this to first name and then this to last name, now it's sorted by first name over here, descending with last name as the tiebreaker.
Okay.
Okay, so SQL has a lot of kind of weird things about it that are very different from other programming languages that you've seen before. And some of those weirdnesses are inherent to being a declarative programming language, but a lot of those weirdnesses are based on the fact that SQL as a language was originally developed in the 1970s, and we just didn't know how to write good programming languages at that time compared to our techniques today. So one of the things that is weird is that if you want to add 2 strings together, you cannot add them with the plus operator. Instead, if I want to add this last name string and this first name string together, what I do is I use these 2 vertical bars like this. Kind of looks like the OR operator in C++, if you're familiar with that, but it doesn't mean OR, it means adding strings together. And so here, this will add the last name and the first name, and this will be returned as a single column with both of those 2 things concatenated together. So I'll hit enter. You can see up here at the top now, it has this sort of question mark column label because there's no like name of this column. It doesn't know what to call it. And then here's all of our names of actors, but the names have all been smushed together, so it's impossible to read. So what we want to do is we'll do last name and then inside single quotation marks, comma, space, and then an OR like that. In Python, you're allowed to use either singular or double quotation marks for strings. In SQL, you must use single quotation marks, like this. And now I hit enter, and now we get this kind of nicer formatting of last name, comma, first name. We still have this sort of problem of at the top. So in the top left, it has this question mark column. And so what we'll talk about now is what's called a column alias, where you specify an alternative name for a column. And here we'll call the column as full underscore name, like that. And now at the top here, it's labeled as full underscore name. So this as keyword right here, what it did is it just gave a name for all of this big formula right here so that we have a convenient way to access it. At this point, the only way this comes into effect is sort of aesthetically, where we see it at the top of our column list like this, but it will have sort of more important syntactic reasons or syntactic things later that we'll see. Any questions so far? Okay. So in SQL, sort of the default is that all column names or all relation names, basically all the names of everything has to be a single word containing only alphanumeric strings and the underscore. If you want to include some sort of weird character in your string, like a space, then the way you have to do that is you surround it in double quotation marks like this. And now I can put a space right here and hit enter. And you see that this column name now does not have a space. So this is confusing because here we had to use double quotation marks and here we had to use single quotation marks. Here, because the single quotation mark, it's like an entry it's actually part of the data. It's being interacted with the data. It's a string that we're concatenating to another data element. That's why we use single quotation marks. Here, this double quotation marks is because this is like the name of a variable and not the data stored inside the variable. So double quotation marks for column names or table names, single quotation marks for the actual data itself. Let's see. The next clause that we'll take a look by is the limit clause. And limit is something that kind of does maybe what you would guess. I'll say limit 10, and that now gives us only the first 10 rows of the results instead of all 200 that were in the table. For very small data sets, it's fine just to use a normal select like this. But for much larger data sets, let's say like you're Google and doing a web search, you don't want to actually return all 1 million websites that the search found. You want to only return like the top 10. And so limit 10 is how you do that. This limit here is what we would call non-standard SQL. It's not part of the SQL standards. I had that link in the README to the actual SQL standards, and this is not part of them. This is a Postgres specific feature. It's so convenient though that it's just implemented in essentially every database. I don't know of any databases that don't support this limit feature. In the sort of those links that I gave you, that postgrestutorial.com, they talk about how to use this limit, and they also talk about a different syntax for doing this limiting using a fetch keyword. That fetch keyword is part of the SQL standard, but nobody actually uses it. People just use the limit because the syntax is much easier to understand. So yeah, in this class, you won't have to, I'll never ask you a question with fetch. I'll only be using the limit And it's perfectly fine to use limit instead of fetch, even though it's not part of the SQL standard. Let's see. So as we can see, I'm adding more and more clauses like this. And so the SQL statements are getting bigger and bigger. And we've pretty much maxed out how much I can fit on a single line right now. And so SQL lets you spread out your commands onto multiple lines. That's perfectly okay. And in fact, that's sort of the standard thing to do. Basically, every SQL statement is kind of like this big paragraph chunk of commands. You can, in your Psql environment, it's fine to just type them out as different commands, one at a time. So I'm going to rewrite this command up here on multiple lines, something like select, and then I'll copy that from actor. It's very typical that, so all of these words that I have capitalized right now, these are the actual SQL keywords for each line in your command to start with one of these SQL keywords. And so we do that as our next one, order by, and then limit 10. And this command gives the same exact results as this command up here. SQL knows that your command is over because it ends in a semicolon, and it stops that command and goes on to the next one. With the, so just like in Bash, when you do the up arrow to go back to previous commands, in Psql you can do the up arrow, and when you have these multi-line commands, it's going to display all of the command at once, and you can still use the left and right to actually go back and edit things on the upper lines like this. So say I didn't actually want this space here, redo it like that and hit enter and get rid of the space. So typically when we're editing these SQL commands, the way that I do this is, well, it can be very cumbersome to just manually type in a large SQL command into Psql by itself because it's just not a great text editor. On Psql, there is a built-in command \E, and if you hit that, it will open up Vim with a with whatever your previous command was that you had run, so that you can edit it however you want. And now I want to replace that underscore back with a space. I can use all my Vim tricks to go over there, do that, WQ to save and quit, and now it reruns that command like this. If I press the up arrow, you'll see that even though my last command was actually \E, it gives me this command like here, what it was actually inside of Vim when I saved it. I'll also very commonly have a separate Vim window open on another terminal. And let's go ahead and go inside of that project folder. And I'll call this SQL or examples.sql. Typically, SQL files will end in the .sql extension. And you'll notice that I'm pronouncing this extension as .sql because it's like actually, I want to be emphasizing that it's the letters SQL here, and it's not the SQL programming language. So Vim examples.sql. And now here, I might type in, let's go ahead and copy and paste this command like this. Type in this command, and now I can have, say, multiple different commands over here that I'm working with and editing them and copy and paste them back and forth for easy usage. One of the things that, at least with my default vimrc file, will be a little bit annoying is that there are these numbers over here. And so if you tried to copy and paste something like this back over here, you'd get those numbers appearing in Psql. And those numbers are not valid SQL commands. And so if I were to hit enter right now, I would get some weird syntax errors. So when I'm working on a SQL file inside of Vim, I'll turn off these numbers, and the command for that is :set no number. And now I can easily copy and paste from one side to the other. So let's see, we have these two commands up right next to each other, and right now the text of these commands is actually identical. And here's where we're going to start talking about the next really weird thing about SQL syntax, and that is that SQL is not case sensitive. SQL is not case sensitive. And that's different from essentially, oh, I misspelled that. There we go. Different from basically every other programming language that's been invented in the last 40 years. Back in the 1970s, people thought it was a good idea to make things case insensitive, but it led to all sorts of confusion. And so people no longer do that. So here, this keyword here, select, I've written in all caps, and it's kind of customary to write it in all caps, but there's no reason to write it in all caps. You can do like whatever weird capitalization that you want for any of these SQL keywords. There we go. And the command will still work exactly as expected. So in the real world, you'll never see somebody do like weird stuff like this, but you will sometimes see everything in all lowercase. And you just need to know not to be thrown off by that. It doesn't matter whether these are in lowercase or uppercase, it means the exact same thing. Let's see, I have a big list in the README file right down here of some of the weird things about SQL. So we've talked about, okay, so white space doesn't matter. You can have as many new lines as you want. It's just the semicolon, case insensitive, and concatenating strings. Now let's talk about string escaping and even weirder quotation marks inside of SQL. So let's come back over here, and I'm going to copy this and paste it down here. And let's say, well, yeah, we're going to add at the very beginning here a new string of I'm not, then whatever the actor name is. And we'll notice that we're getting all this weird coloring issues right now because I'm using this single quotation mark here inside of a string that's delimited by single quotation marks. And in most programming languages, again, every programming language created in the last 40 years, you would escape this string with a backslash like this. In SQL, though, we don't escape with backslashes. You escape by putting your whatever type of quotation mark you're currently inside of, you put two of them next to each other. And that means that this is actually a single quotation mark. So I'll go ahead and copy this over here. And you can see that it's now putting I'm not like this. So if you need to include a quotation mark inside of a string, you double up the quotation mark. And that's true for any type of quotation mark. Sometimes that's a little bit annoying. So we'll be later on in this course having strings that contain strings that contain strings that contain strings. And it would get way confusing if you were escaping things like this all the time. And so SQL provides what are called $sign strings, where you can use a double $sign like this as your string delimiter. And it looks like my Vim doesn't recognize this as valid syntax, but if we go ahead and put this over here, it recognizes that just fine. So here, these $signs are equivalent to the single quotation marks. But because I'm inside of a $sign, now I don't need to double up these quotation marks here. Yeah, you'll see these, again, $signs all the time, and you can, that's what they mean. They're just quotation marks. The next confusing thing about quotation marks is that you can actually create your own types of quotation marks. Here, if I was to say like blah in between those two $signs, then I end the delimiting with blah like this. So this is now a valid quotation mark. Run this command down over here, hit enter. same exact meaning as before. But now I can use double dollar signs like this inside of my quotation, and it recognizes that those are not the same quotation mark and actually includes the double dollar signs. So kind of weird syntax that takes a little bit of getting used to, but this is sort of very important. We'll be running into this sort of syntax a lot, and so you can expect on your midterm to have some questions involving statements with very weird looking strings like this, and I'll be asking you like, what is the actual value of this string? And so in this case, the actual value of blah, I'm not blah would be this right here. Any questions about any of this weird syntax?
Yeah. So to create these the quotation marks, do we have to use dollar signs and like dollar signs surrounding the blah, or can we have anything other than?
Yeah, so it's the dollar sign specifically that create these quotation marks. You couldn't like use hashtags or anything else. Any other symbol would have specific meaning. It's different than this to SQL. Dollar signs are only used for quotation marks, and they are the only things that can be used for quotation marks. Any other questions so far?
Can the dollar signs be used for the column names, like how we saw with the double quotation marks?
No. So the column names have to be double quotation marks. If you wanted a double quotation mark inside, you could do something like that to escape it. But you can't, actually, it looks like you can't even include the double quotation marks inside. Oh, it's because I didn't write the command. I didn't copy it. Here we go. There we go. There's the quotation mark right here, corresponding to this double quotation mark right here. This is the sort of thing that nobody in the real world would, nobody in the right mind in the real world would ever do. But I guess when you're using other people's code, you will encounter lots of situations where you think people are not in their right mind. Let's see. Yeah, so I think that's a good stopping point for us for today. Next time we'll go into some more of these SQL details and also talk about exactly how to interact with the homework and use the test cases for evaluating whether your SQL is correct or not. But that is it for today's lecture. And I'll stick around for a little while if anybody has questions on your homeworks or anything else. I can answer those now. But otherwise, I will see you on Wednesday.